Okay, Minal. So in the last video, we have discussed about Cauchy's theorem for integration when we have a complex function. So before moving to Cauchy integral formula, I would like to discuss one or more or two more problems. Okay.
Okay, ma'am.
Although we have discussed last time also, but there are some problems of different kind. We can discuss those and then we will move on to Cauchy integral formula today. So the first problem is, this is based on Cauchy's theorem only. We were doing the consequences of Cauchy's integral, Cauchy's theorem. One was that the integral is independent of path, and second one was you can deform the curve, right? So this is based on that. So you have to compute this integral along the curve gamma 1 upon z square minus 1 dz, where gamma is this curve, right? So you are given like this. Here is a point 1. Here is a point 0 and here is a point minus 1 somewhere here, right? So you
Yes.
see, this is your gamma. Now we know that if the function is analytic on and inside your curve, then the integral is 0, right? Now if you look at
Yes.
this function is analytic everywhere except at
Minus
z
1.
is equal to -1 and +1, and this point is outside the region because we are just concerned about the region which is contained inside gamma. So this point is outside, so we don't care about this point. So this is the point which we have to deal with. So we already know that how we can do that. We can just make another small circle around -1, right? Make a small circle, make a small circle around -1. This is what we had done in the examples in the last video. So here, now in this region between gamma and this curve, let us call this curve as C. Okay, this is also positively oriented, right? Now in between the region which is contained between C and gamma, the function is analytic. Is that thing clear, Minal?
Yes, ma'am.
Between C and gamma, fz is analytic. Therefore, you have that integral along gamma is same as integral along C. Right? Now your function here is 1 upon z square minus 1 dz. You can write it as, you can just make the partial fractions. So this function here is 1 upon 2 z minus 1 minus 1 upon 2 z plus 1 dz, because we have to separate 1 and -1, right? Now we know what is the formula for this particular function, integral, because this is the circle with center -1 and very small radius. Very small radius means you can specify here also that this circle is such that it is not containing 1. So obviously we are inside the curve, inside the region. So we will not take 1. So 1 is always outside. So this function is analytic on C. Therefore this first integral is 0, -1 by 2, 1 by z plus 1 dz along C. And we have seen that this integral is 2 pi iota. Do you remember, Minal?
Yes, ma'am.
So we have seen that if you have z minus a dz, where C is a circle with center A, any radius, then this integral was 2 pi iota. So here this integral is 2 pi iota. So your answer is minus pi iota. Fine.
Okay, ma'am.
So you can have here till now we had simple curves. You can actually have a problem where you are traveling twice around a curve. So let me give you one example. So we have to evaluate this integral z upon z plus 2 into z plus minus 1 dz, where gamma is the circle mod z is equal to 4 traveled twice in the clockwise direction. Traveled twice in the clockwise direction. Right, now you have to take care here, the direction is also clockwise. So this formula which we have obtained, this is when you are traveling in a counterclockwise direction, right? So because you take theta from 0 to 2 pi, it means that you are starting from here, this is theta is equal to 0, then you go like this and then you come here, right? So this formula is when your curve is positively oriented. Positively oriented means anti-clockwise. It means that when you are perpendicular to your curve, then the region should be to the left, right? So that is why anti-clockwise. So here you see, here you are saying that you have to travel along this circle clockwise, right, twice. It means that if you start from here, go like this and then again one more round. So you have to compute this integral. Now this function is not analytic at z is equal to -2 and z is equal to 1. And both these points are inside your region. So z is equal to -2 is somewhere here. Z is equal to 1 is somewhere here. Right? So first of all, you will separate this and this. For that, you will use partial fractions. So you can just make the partial fraction. So I'll tell you this is 1 by 3, 2 upon z plus 2 minus plus 1 upon z minus 1. So these are the partial fraction for this integrand. Right, now your integral becomes gamma 1 by 3 I'll take outside, 2 upon z plus 2 plus 1 upon z minus 1 dz. Right, now you see, you can just, this is your gamma, so you make a small circle around 1 and make a small circle around -2, both negatively oriented, means clockwise. So you call it c1, call it c2, then we know that. And then also you make, I told you in the last video, right? If there are 2 points of like two singular points, means the points of trouble, there are 2 points. So what we will do, we'll make a circle around here and we will make a circle around here. And then you will also join like this. So you can start from here, you go like this, come back, come like this, right? So you call this curve here, which I have defined, call it gamma 1. So gamma 1 is what? This is C1, right? Or you start from here. So you can say this is L plus C1 minus L plus C2,
Plus C2.
right? And because between the curve gamma and gamma 1, the function is analytic. So this integral here can be computed along gamma 1 only. Right. So now you can write it as 1 by 3 C1 plus C2 plus L minus L 2 upon Z plus 2 plus 1 upon Z minus 1 dz. Integral along L and minus L will cancel. So you can remove this. So this is 1 by 3 C1 plus C2 2 upon Z plus 2 dz plus 1 by 3 C1 plus C2 1 upon Z minus 1 dz. Now if you, this is a circle with center 1 and this is a circle with center -2, right? So this function is analytic for this circle. So integral along this circle is 0 and along C2 will be how much? That will be, you see, 1 upon Z plus 2 will be 2 pi iota. So 2 will be outside into 2 pi iota, but a negative sign because this C1 is now negatively oriented. And similarly
But
here,
ma'am,
yes,
don't we have to travel it twice?
yeah, twice also. For that you will have, uh, yeah, we have to travel it twice. So for that we have, okay. So what we can do, we can just compute, I'm just computing suppose once, right? Then we
Okay.
will just make
Okay.
it twice, right? That you can do at the end. Fine.
Okay, ma'am.
So here, or you can take along the way also. For that, what you have to do, you have to say gamma is twice, and then this gamma 1 is also twice. then everywhere you will put 2. Or what you can do, you just simply compute along gamma. Gamma you treat as one circle, and then you can twice make it 2 times. Okay, Minal? They are
Okay.
both the same.
Okay, ma'am.
So here along C1, the integral will be 2 pi iota with a negative sign because of negative orientation, and along C2, because this is analytic, so along C2 this integral is 0, right? So you
0.
get your integral is minus 4 by 3 minus 2 by 3 pi iota, so that is minus 2 pi iota. Is the calculation correct? Minus 4 by 3, 2 by 3, 1 by 3. This 2 is here, right? Minal, calculation is correct?
Yes, ma'am.
I'm making some mistake, I guess. Okay. Minus 2 pi.
Ma'am, it was not 2.
Sorry?
It was Z, I guess.
Where? No, no,
In
no.
the
That it was Z, but because of this, you'll get Z already. Okay? You do
Okay, ma'am.
this. Right? 2Z minus 2 plus Z plus 2. 2 and 2 will cancel. 3Z, 3 and 3 will cancel. So you'll get that. That Z is removed because of partial fraction. So I think I have done the mistake in my calculations in the copy. So here I think they are correct. So this is minus 4 by 3 and minus 2 pi 2 by 3 pi iota. Yes. And then your final answer will be that you will make it twice. Right. So for traveling twice, so your answer is 2 into minus 2 pi iota. That is minus 4 pi iota. Right, Vinal?
Yes, ma'am.
Okay. So you can also have something like this. Next problem I'll give you. So you have to compute this integral along gamma 2z square minus z plus 1 upon z minus 1 square z plus 1 dz, where your curve is like this. Right. So here you see your curve is not simple in the sense that it is intersecting with itself here, right? So what you
Yes,
can
ma'am.
do, you can just break it. This gamma is the total curve like this. Okay, so sorry, like this. You're going like this. So here, right? So what you do, you call this as C1 or gamma 1 and call this curve, right, as gamma 2. Fine. So what you can do, you can write your curve gamma as gamma 1 plus gamma 2. Now you see gamma 1 is clockwise and this is anti-clockwise, right? So if you want to, then you have to make sure that you are taking care of the signs also. Now you see if this function is not analytic at z is equal to 1 and minus 1, z is equal to 1 is here and z is equal to minus 1 is here, right? Then you have to do the similar analysis, but the only thing is you have to make sure that your gamma 1 is positively oriented and gamma 2 is your, sorry, gamma 1 is your negatively oriented and gamma 2 is your positively oriented. Minal, should I complete it or it is clear?
Ma'am, this figure is clear.
Figure is clear? Okay. So,
Yes, ma'am.
okay. So first of all, in these problems, because we have to separate 1 and minus 1, you always have to take the partial fractions. I'm writing straight away. The partial fractions are 1 upon z minus 1 square, right? Plus 1 upon z minus 1 plus 1 upon z plus 1, right? So this integral is first of all this. Now you break it into gamma 1 and gamma 2. So this integral will be along gamma 1 and along gamma 2, right? And here you will make a circle, small circle. Here also you'll make a small circle. So and the straight line also. Or because here we are just separating the reason, so you can write it as along gamma 1 plus along gamma 2. So you don't have to make a straight line. So this will be same as along C1, right? Here, this is your C1, right? So C1 is negatively oriented. And this is same as C2, integral along C2. C2 is your positively oriented, anti-clockwise, right? So now what you will have, now you compute this integral along C1. C1 is a circle whose center is 1. C1 is a circle whose center is 1. So this integral along C1 will be, right? So center is 1. So this is analytic. So this part will be 0, right? And this part will give you some value. And for along C2, this part and this part will be 0 because C2 is a circle with center -1, and this part will give you equal to 2 pi iota, right? For
Yes.
C2, right? So for C2 here you will get 2 pi iota, simple, right? Is that okay, Minal? Because C2 is a circle with center -1 and positively oriented. So you
Yes,
will
ma'am.
get just 2 pi iota. And C1 is negatively oriented. So this one with center 1. So this one will be 0. And this will give you values. Now you have to tell me how much are the values. So this particular integral will be minus 2 pi iota.
Yes, ma'am.
And this integral, I think we have computed 1 upon z minus a raised to power n also. You can remember the formula. I will tell you. 1 upon z minus a raised to power n dz along a circle C whose center is a. This is 0 if n is not equal to 1. This is 0 if n is not equal to 1. And this is 2 pi iota if n is equal to 1. Right? So this will be 0. This will be 0. So your final answer is 0. Is that okay, Minal?
Yes, ma'am.
So this is how you have to deal with these problems when you have curves which are not simple. If they are intersecting, then you can just break it into simple curves, and then along every simple curve you can apply your techniques. Okay?
Okay, ma'am.
Yeah. So let us move ahead to the next thing, which is Cauchy integral formula. This is very important in finding the values of integrals. Cauchy integral formula. So this Cauchy integral formula tells us, suppose fz is analytic on and inside a simple positively oriented curve C, right? So you have a curve C which is positively oriented. So you will have you will travel anticlockwise, right? Then for any z naught inside C, so for any z naught inside C, you have value of the function at z naught equal to 1 by 2 pi iota integral along C of fz upon z minus z naught dz. So this is your Cauchy integral formula. Because we are doing the summary videos, so we will not prove these things. But obviously in the detailed videos, we will prove everything. So here I'm just stating this formula, but I will tell you that, you see, what is happening here. We are saying that once the function is analytic inside and on the curve C, which is simple and positively oriented, then given any point inside that region, you can compute the value of the function at that point by just computing this integral. Now, when you compute this integral, all you need is the value of this function on the boundary. So, Cauchy integral formula is is kind of magic through which you can just use the value of the function on the boundary, and you get to know the value of the function everywhere inside your region, right? So this is you must have never seen such kind of formula in the function of real variables, right? So we don't have such formula for function of real variables. Minal, is that okay?
Yes,
Do
ma'am.
you get it? So it means that by defining the function only at the boundary, you have defined function everywhere inside the region automatically, provided the function is analytic, right? So this is quite useful. For example, if you have this, compute this integral. Integral along C e raised to power z square upon z minus 2 dz, where C is this curve. Here is your 2, right? So you see here, if we try to apply our previous technique, then what we will do, we'll say that this function is, then applying this technique is little difficult, right? Because you don't have only z minus 2 dz. This we know that this is equal to 2 pi iota. That only when you will just, this is your curve C, then you will make a circle, because this is not a circle with center 2, right? So this is true when your circle is with center 2. So you will make a circle C1, and then you will say that integral along C is same as integral along C1. But here you have this e raised to power z square also. So your last technique will not work. Understood, Minal?
Yes, ma'am.
You cannot get rid of this e raised to power z square. Now let us see what Cauchy's integral formula tells us. So here you see e raised to power z square is analytic everywhere. Indeed, it is an entire function. Entire function matlab it is analytic on whole complex plane, right?
Yes,
So
ma'am.
it is analytic everywhere. And z is equal to 2 is inside the region. So it means that if you look at this integrand here, this looks like this fz, which is e raised to power z square. And in the denominator, you have z minus z naught. So here you have z minus 2. So from
Yes.
here, you can also write it as integral fz upon z minus z naught dz along C is equal to 2 pi iota times f of z naught, right? So I can write this integral as 2 pi iota times f of 2, where your f of z is e raised to power z square. So this is 2 pi iota times e raised to power 2 square. So this is 2 pi iota e raised to power 4. So this is your answer. Got it?
Yes, ma'am.
And same question, suppose your curve now is this. So what will be the answer? You have to tell me, Minal. Now your 2 is outside the curve.
So it would simply be 0, ma'am.
Yeah, 2 is outside the curve. So this is analytic. Therefore,
Yes,
by
ma'am.
Cauchy's theorem, it is 0.
Yes, ma'am.
Right? And suppose you have like this. 2 is here. And then you have, this is your curve. Right? Like this. You're going like this. You're starting from here. Like this, like this, like this, like this, this. So your curve is making 2 rounds around 2. So in this case, what will be the formula? What will be the answer? What we can do, we can break, this is your total curve C. So we can break this curve. What I can do is, I can take this much part, this part. Okay, positively oriented or
Yes, ma'am.
negatively oriented?
Negatively.
Negatively oriented, right? And then you can take this part also. This is one closed curve, which is in blue line, and yellow also is one closed curve. So you just call this curve as C1 and call this curve as C2. So your integral along C will be C1 along C1 plus along C2. Is that thing clear?
Yes, ma'am.
And they are simple curves now. This C1 is a simple curve,
Yes,
right?
ma'am.
And C2 is also a simple curve, right? So they are not intersecting with themselves, C1 and C2 separately. Now along C1, you see again, you have C1 is a curve, and this function e raised to power z square is analytic, right? So according to Cauchy formula, this will be minus 2 pi iota f at 2, negative sign because of negative orientation.
Yes,
right?
ma'am.
And for this also you have this is equal to minus 2 pi iota f of 2, right? So this is minus 4 pi iota f of 2 e raised power 4. So
4.
this is your answer.
Okay.
Okay, so I think we can stop or we can go for one more problem with us. Is that okay?
Ma'am, we can go for one more problem.
Yeah, okay. So we have this problem based on Cauchy integral formula only. E raised power z plus sine z upon z dz along tau, where tau is a circle. Tau is a circle. Mod z minus 2 equals to 3. Traveled once in counterclockwise direction. Traveled once in counterclockwise direction. So you have to just see is z is this is z minus 0. So 0 inside this or not?
Yes, ma'am, it is
Yeah,
inside.
okay. So you have this is a circle with center 2 and radius 3. So 0 is here. So this is minus 1. This is 5. Right? So 0 is inside. So you can straight away, and this function is analytic. E raised to power z plus sine z is analytic everywhere. So
Yes,
this is
ma'am.
analytic. So this by Cauchy's integral formula is 2 pi iota f of 0. So this is 2 pi iota e raised to power 0 plus sine 0. E raised to power 0 is 1, sine 0 is 0. So this is 2 pi iota. So your answer is 2 pi iota.
2 pi iota.
Okay.
Yes,
So
ma'am.
one last. So you have integral along gamma z square e raised power z upon, you have z square e raised power z upon 2z plus iota dz, where this is a circle, this gamma is a circle, mod z is equal to 1, traveled once in clockwise direction. Traveled once in clockwise direction, right? So here you see what is you have to make it in that form. Here you have 2z plus iota, you just take 2 common. So this is z square e raised power z by 2 divided by z plus iota by 2, right?
Yes, ma'am.
Now this function is analytic everywhere, so you don't have to worry. And this point minus iota by 2 is inside the circle. You can see,
Yes,
right? Therefore, this by Cauchy's formula is equal to 2 pi iota into value of the function at the point minus iota by 2. So that is minus iota by 2 square e raised to power minus iota by 2. This is your answer, pi iota by minus iota by so this will be negative. Also this is clockwise direction, so you will have a negative sign, right?
okay.
So you have to make sure, otherwise it will be wrong. So clockwise direction you have to make negative sign. So minus iota I square will be minus 1, so this will be plus 1. So your answer will be pi iota by you have 4 here, and this 2 is also there, no? This 2 we are missing, this
Yes,
one,
ma'am.
this 2, right? So this 2 and 2 will cancel, and I had 4 e raised to power minus iota by 2. So this is your answer.
Yes,
Okay, Vinay?
ma'am. Yes, ma'am.
So you can also sometimes you have to play with this integrand to make it in the form where Cauchy integral formula can be used. For example, if you have something like this, say cos z upon z square minus 4 dz along a curve tau, where the curve is like something like this, right?
Okay.
2 is here. Now you see here in the denominator you have z square minus 4. So this is
Yes,
a
ma'am.
function which is not analytic at z is equal to 2 and minus 2. And we want to, we can see that z is equal to 2 is inside our region gamma, inside the
Yes,
curve gamma. So you can write it as cos z upon z plus 2
yes, yes.
upon z minus 2 dz.
Yes, right.
Right? Now, if you look at this function, this is analytic everywhere except at z is equal to minus 2. And z is equal to minus 2 is not inside our domain. So this is analytic on and inside gamma. Analytic on and inside gamma. Therefore, by Cauchy integral formula, this is 2 pi iota f of 2. So that is cos 2 upon 2 plus 2. So that is pi iota by 2 cos 2.
Yes, ma'am.
Okay. So we can play with the integrand so that uh, our function which is in the numerator is an analytic function, and in the denominator you have z minus z naught, where z naught is a point inside your region. Okay, Minal?
Okay. Okay, ma'am.
Yeah. In the next video, we will dwell further into this Cauchy integral formula. We will discuss Cauchy's integral formula for derivatives. Okay.
Okay.
Okay, Minal, if you have any doubts, we can discuss those doubts now.
No, ma'am, it's okay.
Okay. Thank you, Minal.
Thank you,
I'll
ma'am.
just stop the recording.